On today's episode of Future Says, we have Francois de Higre, Senior AI Fellow at Michelin. With over a decade's experience, Francois has always been a champion for integrating data into engineering and product design, while he's currently driving the idea of hybrid artificial intelligence, where simulation meets data analytics. Hello and welcome to Future Says, Francois. Thanks very much for joining the show.
Hello, Sean. Thanks for having me here. It's a pleasure to have some time with you talking about interesting AI for engineering topics and beyond.
I am super excited. I've read up on a lot of the things you've presented previously, Francois. I think your message and conversation around hybrid AI and how to apply AI in engineering is going to be fascinating. So very, very excited. But to kick things off, let's start at the start and say, your background is from mechanical engineering. That's what you studied initially. And now you're, of course, a senior AI fellow at Michelin. So how did that career transition happen?
Yeah, the question is, did I move from mechanical engineer to data scientist, or did the world of mechanical engineer is moving toward a little more data-driven activity? I don't know. I mean, I didn't make any specific change to move from one to the other. I think I'm a mechanical engineer by training. That's my engineering master. But then I did a PhD on machine learning to help solving problem about uncertainty quantification. So basically the topics there was you are playing with mechanical structures, but what is the probability of failure of the structure? And basically to try to solve that, we've been starting to use probabilities and statistics to try to assess those very low probability, and it brings us to, having a lot of finite element simulation to play with, a lot of data to assess, a little bit of statistic to try to measure what are the risks. And so this is where I'm starting to understand the benefit of data and statistics when it comes to mechanical structure design choices. Then I would say that over the past 15 years, it has moved from a consulting sort of service where you do a one-shot sort of study, you play, etc., to something a little more automatic, systematic, embedded into the IT systems with a little more data-intensive activity. And today, I would say that in Michelin, the role I have is about making sure that the data science and AI is growing over the different domains. So the engineering is my key domain because this is where I'm coming from, but I'm also looking at the way we are using data and AI in supply chain, in the connected world, sometimes in the manufacturing as well.
Can you talk about some of the differences, actually, Francois, between those domains? So engineering, supply chain, connected devices. How do the AI applications and the methodologies change between those areas?
I would say that the main differences are between the customer of those applications. When you are inside the engineering design space, you are talking to people that have historically a good data-driven understanding. They are all taking decisions based upon facts, based upon test results, based upon simulation results. So they have quite already active on that. So the data is just a way to accelerate, make it more close to reality, instead of having a few tests, and then you're able to combine basically everything you got with respect to a given structure or a given material recipe to try to extrapolate a little more or accelerate the capacity to find the right trade-off between the performances that you are looking at. So that's something that's happening on the design. When it comes to manufacturing at the Michelin world, it's the scale is completely different. So if you are playing on a problem of computer vision, for instance, where you try to evaluate the quality of the product in a instant fashion, try to be fast and precise. Once you get a nice idea, then you have to push it to 100 plants, different scenarios, different machines, different age, different IT connectivity, and so that scalability is something a little bit crazy when you think about it. And then when it comes to I don't know, the business. I think this is where you have to bring a little more data-driven organization. People have been, sometimes using less data than in an engineering world. And depending of the maturity of those domains, you need to go a little bit more to the end of the application about the what you're going to be doing with that, and try to, emphasize the work on the user experience and what it means for the final user. And then when it comes to, connected for us is also the scale, the real time, the embedded systems, the signal processing aspect of it. At Michelin, we've been starting to play on that probably around 2015, maybe a little bit before, trying to capture the usage of our user. That would mean embedded some GPS and accelerometers within cars to try to understand what is the real life of our product. And it leads to a lot of data collection sort of activity in addition to the AI. And then the scale, the big data, the 4G connection, the worldwide aspect of it. This is, it's a little bit different than being in your, let's say, your simulation domain where you have access to your cluster and you are just, sending simulation to generate your data. So there's some differences.
Can you talk to us about the product development lifecycle? That's obviously something that's existed for always, and Michelin have been making tires for over 100 years. Can you talk about somewhat a step-by-step approach and how at every step you see the potential for enterprises to be using AI and technology like this?
At Michelin, I would say at first there's a lot of knowledge in the material science. So I can say that part of the innovation that we have is embedded into the recipe that we are using and into the material that we are using. So there's the first initial guess of how we're going to be solving, I don't know, the snow traction or the dry friction, or I don't know, those sort of multi-performance stuff from the material side. And then you try to move from there's a quote that we used from the molecule to the vehicle, that sort of stuff. So you start at the molecule level, starting to guess what would be the right mix, and then slowly you start to increase the scale. So you move to the piece of rubber maybe, and then the structure of the tire, the one tire, how it reacts to, I don't know, load, traction, etc. And then you place that tire on a car, get to the real feeling of the performance. And then when we move to services, etc., we place those cars in a fleet, and we have to control the overall fleet and the overall maintenance. So if you think about it, the data and the data needs are, and the application and the use case are across all that stuff. So today we think about it to improve the material recipe optimization. We think about it to optimize the geometry of the tire. We think about it to, have a better description of what is the true performance on the market, because, the performance that we measure inside and the performance that is read or understood by the end user are sometimes different. And so there's all use case across those ideas. But what's funny is that, so we've been talking about the different domain of data at Michelin, but then when you are inside one, like the engineering, it goes from a molecule to the vehicle, and across all that, there's some data-driven decision to be made and some interesting topics to explore. That's pretty fun.
And I want to pick up as well, because you sort of mentioned, as you said, the molecule to the vehicle, and a lot of these vehicles now, they're all connected, and there's a feedback loop between that in-service operational data back into that design. Earlier in the podcast, we had the head of digital twin at Ford speaking about digital twins. I wanted to get your perspective on that term. Is that something you seek? Do you define it as a digital twin? It's a term that is defined differently by everybody. But I want to open that up a little bit on what that means to you. Is that something you employ a lot?
Yeah, like you said, so digital twin is something that is used across different métiers and across different needs, from the product lifecycle management sort of idea, the CAD part and its evolution across the timeline from the very early draft to the one that's produced. So there's some sort of digital twin of the build process. Then you can have a digital twin from the simulation perspective. Okay, you said the performance are all predicted by some simulated models to help you play with the trade-off between performance, and then there's the real time sort of digital twin, right, where you have some sort of a virtual picture of that tire that you place under that car and how it reacts. What is its current shape today, current state today? Is it close to its end of life? Is it secured? Is it close to be won? I mean, there's all those definitions. For me, if I think about the digital twin, it's closer to that last picture of it. I'd like to be able to have some sort of an end-to-end view of my product in its use. So I have my picture of it. Maybe it's a 3D CAD, or maybe it's a data definition of my product, and I'd like to update that state with data coming from outside, from its real use. I think that being able to connect the design aspect to the user, this is great, And then in addition to having built that first link, maybe it is by building a metric that is able to capture the internal state of the product. Is it safe? Some sort of endurance criteria, for example. Once you have that end to end, then you can start adding more data, more descriptor to it to try to make it better. For example, information from the manufacturing or information from different aspects to the thing. But I think that the first link that I want to make on that digital twin is a real string between my design world and my user world. That's that's my thing. More than having an internal end-to-end view of it, I think the digital twin for me, it's where we connect it to the real life. So that's where I'm starting the stuff. So it means that it can be simple. It can be just I have a machine and I have a digital twin of the machine, because in real time I can give you insight about where you are with respect to your product, and I can help you make the better of it, and also through that understand how you are using it and what you need, and so to improve it. I think the digital twin for me, it's that link that sometimes has been missing in the past between the design world and the user world, right?
And so many use cases and opportunities and ideas already, Francois. So this is really fascinating. With all of this potential, and it's endless, the potential, there's so many different areas we could look to do, as you've already mentioned. So at Michelin, when you think about AI and you think about projects and you think about POCs or use cases, is there sort of a checklist that you need to tick off before you launch any? That you need to say, okay, well, we need this amount of data, or we need this success criteria in order to do it, in order to make that a success? How does that work?
I would say that we have a different point of view depending on the domain. There's some domains where we are playing with a use case list and some sort of maturity check, and we make sure that the data is there. We usually make sure that there's some pull by the business, right? Some value that is behind the scene on how or why we would start a use case. It's good to have use case to demonstrate value, but then it's another piece of work to truly from molecule to vehicle have everybody thinking in a data fashion and consolidating our data assets in order to accelerate the improvement to our data driven. So I'd say yes, we do have portfolio management, trying to play with low hanging fruit use case. Still keeping some what we call moonshots or advanced topics, something there where we want to go, etc. So I'd say that we use the AI transformation by the book, like some. But then I think what differs maybe is that we feel that the métiers are in charge of their own transformation, So it has to be embedded into those business line or operational direction. And the research one is something that matters the most to me. And so we are trying to say it's not about use case. It's about having everybody thinking data driven and bringing the data within their current decision process. So of course it goes through use case, but I'm looking to something a little more let's say embedded into the organization.
Two questions off the back of that. I want to get into how you embed it, and I think that when we start thinking about culture and changing the mindsets internally, and I want to ask about the team and everything else. But firstly, if possible, you mentioned two ways you do it, which is by the book. I couldn't agree more. Low-hanging fruit and then moonshots. Is it possible to give an example of each? One low-hanging fruit project that you've done successfully, one moonshot that you've done successfully.
For example, something that we've been doing for quite some time, and this was almost something I was doing after my PhD in my first company. But it's basically optimization based upon a reduced order model that you are building through what we would say synthetic data, basically a finite element model, right? So we have simulation, and historically, designer would get their own pass to the optimized point or to the trade-off, right? So they would start somewhere, play on a watt factor at a time sort of approach, move a little bit and try to reach the optimization, demonstrating that through a simple design of experiment and an AI model or a reduced order model or a real-time sort of a exploration capacity, get to play with the trade-off and not only with the black box model, but also with sensitivity information, with what if scenario capabilities, all that has been quite successful. And that's for me, super easy, right? We've been doing that for quite some time, but sometimes just for us, like I can do this for myself. I think the value of those AI transformation is how can you push the value up to the user. So not spending too much on the technology part, but spending some time to valorize, get some key user, get some I would say Instagrammer, like people with influence, locally, try to have that organic way, and then to the other direction, like to the more moonshot stuff. We are playing with generative stuff, variational autoencoder in 3D. Would this change the way we do the tire sculpture? I don't know yet. But this creates a lot of let's say expertise inside. It helps us to play a lot with data. So even if it's a moonshot, along the way you are learning a lot about the tools, about what works, what not, and so those generative for 3D for material recipe. That's somehow our moonshot. I cannot tell you when we're gonna have a AI generated formula that's gonna be embedded into a product. Today, I would say AI helped driven formula. It's already the case, but AI, fully generated. I don't know, but still, that sort of direction is pretty interesting.
Well, it sounds like it's a pretty awesome team to be working on, Francois. This is really interesting. All these projects, I'm quite excited. But tell me then on that. I mean, who is the team? Like, who works on AI at Michelin? Is it data scientists? Is it engineers? Multifaceted? How does it work?
It's a mix of everything. So again, it depends on the domain. I think some are more let's say data engineering intensive. Some are more related to the engineering aspect of it. So I would say it has grown from those different point of view. When it comes to AI for engineering, I would say those are, I would say 50% of people like me, background in mechanical engineering, follow up some uncertainty qualification, and let's say more numerical aspect of it. People who have been playing with optimization, applied mathematics, I would say. And then we also have people with a background in computer vision. There's quite a lot of folks with a PhD in that sort of field. We've been building up on internal resources, and then for sure on top of that, then we are hiring people with the data science background. But because I feel, or we feel, that the métiers are an important part of it. I do prefer to embed those directly in the métier. I feel like the general AI is something that we learn at school. That's our common background, probably. But then you need to find a métier, find a domain, and accelerate your knowledge there. Have some sort of true deep expertise there, right? Instead of knowing all the algorithm, I'd rather have you knowing a few that matters to you and that you bring end to end within your domain. So that's how I'm trying to, let's say, manage expertise, and that's my role. I'm an expertise manager at the group, so that's how I'm trying to do it. Just trying.
Makes a lot of sense. Yeah, I completely agree again. So how do you do it then? You have how do you get these people to move into the domains, to upskill on both the domain and maybe on data science, or maybe data scientists on sort of simulation? Is there this upskilling way?
I think they are finding interest. You know, if you are if you fall into a domain, and people who are very interested in transforming their métier to something a little more data driven, bring AI. I mean, it gives you opportunities to make impact closely to the business, and so it shows interest, and then it creates attraction to you. I feel like when you fall into a group of people trying to make a change, it's quite interesting to be part of that team. When you want to bring the product outside, at some point you push the button to start the production, right? And that guy still need to have completely trust on what he's putting on the field. And so if you bring AI inside that, then it has to be trusted. It has to be good. It needs to be the complete risk needs to be understood. And so we've been doing a lot of discussion with the business to try to understand what is the data model, what is the simulation model, what are the risks involved, what are the precision, how can we validate the sensibility, the bias, etc., etc. This is critical, right? So I would say, in addition to be good technically, making sure that you can start that conversation with the business, understand what is at stake for them, to make sure that the metrics that you are using are going to be the one that has value, that has value for them.
And yeah, so it's education, making people understand what this is doing, so they trust it, as you sort of say.
Yeah, and for some reason, so it all goes back to statistics, right? Because and for some reason, engineers they don't like statistics. I don't know why. I was kind of happy to play with that, and so for me, that AI sort of wave is a way to bring back statistics onto their desk, but in a different fashion, is in a more what if scenario sort of game, play with data, so more facts than distribution.
Are there other sort of ideas that you have, like you say? I think you said games and I don't know, workshops or hackathons, or how do you actually do that? Do you have webinars, lunch and learns? Are there things like this?
So I have always found like numerical stuff and data viz and risk estimation to be fun. It's quite a puzzle to me, and so maybe I have tried to try to push that to my let's say users. I would say I've had a lot of fun playing with the open source attractivity. I would say the community aspect of it, the eat your own dog food. If it's good for you, it's going to be good for someone else. The make it beautiful. Always look at that extra mile that you might say to bring some attractivity to the final user. So that's my tip. I don't know if it works. I don't know if it's if you can make it a general feeling, but that's usually what I'm trying to do, is to put myself in those shoes. And as a mechanical engineer, I'm referring a lot to the work of the tire designer and the material designer. I could have been in their shoe, and the tool I'm trying to bring is the one that I would love to be using every day to try to make decisions about my product. And then there's quite a a few resources that I've been using that are trying to bring that gap between the theoretical aspect of AI and or data and the engineering world. I'm thinking about Bayesian method for hackers, that book. And there's also some video about statistics for engineers or statistics for hackers. Trying to play with Monte Carlo in a very simple fashion. Just look at the decision risk in a fun fashion. All those are quite useful to make the wow effect and say, oh, that's what you are talking about. That is statistics, but I can do that. It makes sense. And once you get to that, it makes sense sort of feeling, then it's a win, right? And this is where you go beyond the use case, I would say.
Yeah. I can't believe how fun it sounds to work at Michelin. This is fantastic. Yeah, I love it.
I mean, I'm trying to have fun with it. It's somewhat quite interesting. It's an interesting time. I feel like I'm starting to scratch the surface of bringing a working environment that is close to what I was expecting 10 years ago. When you were playing with probabilities, but not having true data to infer your model, not having real observation to try to compare your survival, analysis that you are doing. Now we have more data to evaluate our assumptions to compare to, and then the open source stack, the speed of it, the capacity to have support that goes from a very machine learning 101 to variational encoder that has been done yesterday by some postdoc in some country. That sort of huge variety of information you can find whatever your level. I would say this is pretty fun. And so my job is to make sure that all that knowledge base, all those tools, all those way of thinking are accessible in our group. They can have access to data. They can have access to computing. It's easy for them to relate those two, and that's what we are trying to do. Beyond yes, we want to deploy some use case, and we want to try to bring some automation here and there, optimization here and there, but truly changing the way people are doing their day-to-day operation, their support to a business. There's an OEM calling. There's something wrong somewhere. How do you solve that? Then you have already the tools, the data to refer to, etc. That's the kind of working environment that I want to build beyond solving some use case that we choose from accessibility value sort of a trade-off, right? That's the kind of game, and I think this is fun.
So you see sort of data science and, let's say, data-driven methodologies becoming completely standard amongst all engineers?
I would say that would be my target in terms of data-driven company. Maybe not on all domain, but in engineering, I would say yes. When mechanical engineer are going to be called again mechanical engineer, when physician are going to be called again physician, but part of their toolkit, of course, they're going to be some data. It was already the case, but maybe the scale is different. But that's what I'm calling P-shaped engineer. That's a visual that I've taken from I don't know where it's coming from, but the one that I read was Jake van der Plas blog post. There was some P-shaped. So basically, you have to have a domain. You understand that domain. Probably you have some science general expertise. That's the horizontal bar, and then you have a second leg. The second vertical, which is data, computing, statistics, decision making. This is your P-shaped sort of approach, and that's the target for me as a data-driven engineering world. That's kind of my target.
Yeah. So before we conclude, I want to briefly talk about some new challenges that might be coming your way. So a lot of what I've heard today is really exciting, and you're doing so well. Of course, you spoke a little bit about the challenges to get here. Like 10 years ago, how was it different? A lot of people on the show have spoke about culture being a big challenge. It seems like you're making big steps in that regard too. Is there anything that concerns you as you move forward for the next 10 years in terms of obstacles that are only increasing. In order for you to achieve those goals, what's really standing in your way?
So I would say I may be exciting everything because we are making those steps, but we are not there yet, right? So I would say that this is my direction, and then there's a lot of obstacle to make it happen. The fear, the culture, the people that are afraid of losing their I don't know, their weight on the decision process. There's a lot of challenges, but I think the excitement is part of my change process, right? I want to bring that up. There's a lot of challenges that are outside of the data driven. I would say that those challenges of the world changing is a little more impactful on those transformation. I don't know what I should say about those challenges, but for me it has more impact. And basically, I feel like if you succeed in making a data-driven organization, not because of the technology of it, but because of the mindset scientists bring, the collaborative aspect, the fact-driven, the organic sort of collaboration between the historical silos, manufacturing, design, material, etc. You are breaking all that, making another, let's say, collective organization. I think this is very important, not only to be successful in the digital transformation. that's not my goal, but being successful as a company to effectively look at the new challenges together. Yeah, that's for me the challenge, right? So digital organization, yeah, sure. Data driven for sure. But what it means in terms of how we work together, how we collectively build new product or build more sustainable product or even build new domains of product. I mean, Michelin is shifting a lot toward connected for sure, but also toward high-tech materials in the mechanical domain, for example, or and so having all those smart engineers being able to work together to achieve some goal regarding the user needs in a collective fashion. Yeah, that's a challenge, but and that goes beyond digital P-shaped organization. And that's what I like also about those transformations. It's what it brings behind the scene in terms of how we collectively work. That's the challenge.
Why does it matter? It matters because we're making better products, more sustainable products, making products faster, and we're making new products, like you said.
Exactly. So it's not only being efficient in what we've been doing for the past 100 years. It's to be efficient to bring the right product at the right person tomorrow with respect to all our capabilities, manufacturing, material science, numerical simulation, mechanics, usage understanding, vehicle stuff. I mean, all that, bring together, we can tackle different challenges, and I think we'll be stronger if we have that sort of agile and organic organization. That's a challenge.
It's a no-brainer. François, merci beaucoup.
If there's some fun in addition to it, it's okay too.
Yeah, of course. François, really appreciate your time. An excellent episode. Really exciting future. Really exciting team at Michelin. Merci beaucoup. And I'm sure we will speak again soon.
Hopefully, it was nice to have that exchange with you. Have a good day.
Merci. Thanks for watching. Now, next up on Altair.com/Future Says will be Jan Czerkowski, Vice President of Analytics and Fleet Operations at Kongsberg. Hope to see you there.